Welcome to Concept Based. I'm John Hepworth. And at the start of this video, I just want to acknowledge that you may not be a Year 11 advanced student that's looking at this, because if you're a Queensland student, you would be a mathematics method student. And if you're a Victorian student, you'd be a mathematics method student also. And your syllabus structures are a little bit different to the New South Wales one, so it could be in a different order. You might be watching this video later in the year if you've done a search via topics. But I am going to continue to quote out of the New South Wales syllabus. Obviously, there's lots of crossover everywhere, but if you are in another state, then please just double check on your syllabus that it does apply to yours. So let's have a look at this question today that is out of Working with Functions for Year 11 Advanced in the Constructing and Using Functions section. This whole section is quite easy. Almost all of it deals with linear functions. There is a point right at the end that says model and solve using quadratic functions, but most of it is linear, and it talks about using linear functions to solve real-world problems. So here we have an example, and it actually even uses the break-even point. So here we have an example where we've got a real-world application of some linear functions simultaneously occurring in this business, and we want to go ahead and find this break-even point and then give an answer based on it. So the question being, a business has a cost function of C of U and a revenue function R of U. Find the business cost at the break-even point. Now, to do this, in Year 10 and even Year 9, I believe, you will have solved linear functions simultaneously a couple of different ways. You would have solved it by simultaneously solving equations, and you would have solved it by elimination. Now, typically, elimination can be much faster, especially when you have complex linear functions that have fractions. But in some situations, substitution can be much quicker. And this break-even point one is definitely one of those situations where substitution is quicker. The reason being is that our break-even point occurs at a very special point when the cost of the business is equal to the revenue of the business. That's what break-even means. So when we are spending money and making money at the exact same point, we break even. So if something is equal to something else like that, then it really does give rise for substitution, because we could substitute either of these into each other. And that's going to create an equation that looks like this: 5u plus 40 equals 6u minus 100, which is a very simple simultaneous equation to solve. We don't need to go ahead and do an elimination method and try and cross multiply by 5 and 6 and then find out what our final u value is. So try and you do enough of these simultaneous equations so that when you look at them, you can identify which method's better for me to use. Don't just stick to one method and go, this one always works, so I'm always substituting, or this one always works, so I'm always eliminating. It's better to have both of them in your tool belt, because different applications for different things. So here we're taking away 5u from both sides, and we get 40 equals u minus 100. Very easy solve for simultaneous equations. On this one, we're going to add 100 to both sides, and we're going to get that u is equal to 140. Now, I mentioned that this section, or this part of the syllabus, talks about words like justify and conclude, and in the bit I'm working with this question from, in the context of the problem. So just be very cautious that you don't just come up with some numerical solution and then just stop, because you need to be giving your answer in the context of the problem that's being given. So this one is talking about finding the business's costs. Okay, so what we actually found was not the cost. What we found was the number of units that would have to be sold to identify or to achieve this break-even point. But what we actually want to do is identify the costs for the business. So if we now go ahead and substitute the u that we've found into our cost function, so now we have the cost at 140 units equals 5 times 140 units plus 40. Now, I don't know if you're the sort of student that just wants to go and put everything into your calculator all the time. If you are, I would definitely recommend that you don't just straight away use that method all the time, because what can happen is you can train yourself to just punch something into a calculator and just trust the calculator 100%. And if you make a keying error when you're under pressure, working quickly in the HSC, then your ability to understand that you've made that error in that fast typing can be minimized if you're not using sort of mental arithmetic along the way. So I definitely encourage and demonstrate out the front of the classroom all the time that using mental arithmetic is definitely something we want to hold on to so that we can confirm that our answer makes sense. So in this case, 5 times 140, 5 lots of 100 are 500, 5 lots of 40 are 200, so 700 total, plus 40 gives us 740. So, you know, if we got an answer out of our calculator, 1000 and something, hopefully we'd identify pretty quickly that we've made a keying error, which if we just trust that calculator 100%, we might not identify that. And now, as I mentioned, it says answer this question in the context of the problem. So I would probably even state here that the business cost at the break-even point and obviously the revenue would be the same because that's the break-even point, is $740. So I've even made a sentence that it's a terrible that's actually a terrible sentence, hard to write on the bottom of my laptop screen. So yeah, I've still made a relation back to the context of how we solve that. So even though this question, as with all questions that I do on this channel, is solvable very, very fast and very, very simply, I really want to draw out those parts that are actually important here. Sure, it's great that you can do simultaneous equations, but can you use all of the methods and are you choosing effectively? Sure, it's great that you can get your solution, but are you relating it back to what the question's actually asking and stating something that demonstrates your understanding in context? So take those things into consideration when you're answering multiple questions like this.